The water is already in the streets. It is pushing against doors, lifting cars, crawling into ground floors that were dry a few hours ago. On one island, emergency crews are hauling people out of brown, moving water. On another, roads are closing under rain so dense it erases distance. And on the Big Island, while Hawaii watches the sky for the next wall of weather, Kilauea is still alive, breathing sulfur, building pressure, and sending lava up through a crater that has never really gone quiet. This is the kind of moment that looks impossible from far away. Hawaii, the postcard version, is supposed to be beaches and light. But right now, the state is dealing with two threats at once, one falling from above, one rising from below. And the most dangerous part is that these do not sit side by side as separate disasters. They overlap inside the same fragile system. At first glance, the headline seems simple enough. A severe storm has soaked the islands, triggered flood warnings, rescues, evacuations, road closures, and damage that may reach into the billions. At the same time, one of the most active volcanoes on Earth remains in eruption. Water and fire, storm and magma, two extremes colliding in the same place. But that is only the visible surface of the story. Because in Hawaii, floodwater does not move through ordinary terrain, and volcanic activity does not stay politely inside a crater. The land itself is built by eruption. The mountains that wring rain out of the sky are volcanoes. The valleys that funnel torrents toward neighborhoods were carved into volcanic rock. The air that carries storm moisture is the same air that can carry sulfur dioxide and volcanic haze across entire island chains. What looks like a coincidence is, in fact, a system revealing itself. The flooding alone is large enough to alter the rhythm of an entire state. In some areas, officials have described it as the worst flood emergency Hawaii has seen in 20 years. More than 5,500 people have faced evacuation orders north of Honolulu. Hundreds have already been rescued. Parts of the islands have taken extraordinary rainfall totals in a matter of days, with some locations logging 40 to 50 inches over a 10-day span, and more rain still expected. The ground is no longer absorbing much of anything. That matters because in Hawaii, once the soil is saturated, the next few inches do not simply soak in. They convert into motion. Water begins to run, then race, then carry debris, then tear at roads, culverts, drainage channels, foundations, bridge approaches. By the time a flood looks dangerous, it has often been dangerous for hours. And then there is Kilauea. Not in some vague geological sense, not as a sleeping landmark waiting for a future documentary. Right now, the volcano has been in an unusual episodic summit eruption phase since late December 2024. It does not erupt continuously in one steady cinematic stream. It pulses. Pressure builds beneath the surface. Instruments record inflation. Then the system flips, pressure releases, and lava fountains into the air from vents inside Oʻahu. The pattern repeats like a heartbeat written in magma. Some of those fountains have reached more than 500 meters in height, roughly the scale of a skyscraper laid upright in fire. Even when the lava remains contained inside the summit crater, the hazards do not remain neatly boxed in with it. Sulfur dioxide drifts downwind. Glassy strands known as Pele's hair can be carried by changing winds. Visibility can drop. Air quality can deteriorate fast. That is where the hidden story begins, because the same weather pattern driving the flooding can also rearrange the volcanic risk. Hawaii is now dealing with storms associated with what meteorologists call a Kona low, a slow-moving area of low pressure that forms near the islands and pulls in warm, moisture-rich air. The effect is not just heavy rain. It is prolonged instability. It is rain fed from the wrong direction, trapped against steep terrain, intensified by topography, and slowed enough to keep unloading over the same districts for hours or even days. The common image of tropical weather is a fast-moving squall line, a burst, a passing threat. A Kona low is different. It can stall, it can linger. It can let one island drown while another waits for the next band to arrive. It can shift winds, break apart normal atmospheric layers, and change where both moisture and pollution travel. Most of the year, Hawaii's trade winds and an atmospheric inversion, essentially a lid in the lower atmosphere, help contain volcanic haze near the Big Island. Under ordinary conditions, VOG from Kilauea tends to remain concentrated in familiar downwind areas. Communities know the pattern. They understand where the smell will be worst, where the air will feel sharpest, where the horizon will turn dull and metallic. But severe storm systems can break that pattern. A Kona low can weaken or disrupt the inversion, reverse the wind field, and increase vertical mixing in the atmosphere. In simple terms, it can pick up what usually stays local and send it somewhere else. That means a weather event already reducing visibility and creating flood danger can also spread volcanic pollution to islands that normally avoid the worst of it. This is why the flood and the volcano are not separate headlines sharing the same week. They are interacting through air, land, and infrastructure. When heavy rain arrives, emergency response depends on roads staying open, helicopters having visibility, shelters operating with power, clinics handling respiratory strain, and people being able to move quickly. But if volcanic gases and fine particles are redistributed by the storm itself, then evacuation and response become harder. Not because lava is suddenly pouring into floodwater, but because the island system is being stressed from multiple directions at once. A flood does not need to touch the crater to be worsened by the volcano. It only needs to collide with the same atmosphere. And Hawaii's geography magnifies everything. These are islands, but they are also mountains, some of the tallest on Earth if measured from the seafloor. Moist air does not drift casually across them. It is forced upward. It cools, condenses, and drops rain with startling efficiency. The slopes turn weather into water. Ravines and gulches that seem empty in fair conditions can become violent drainage systems in a short span of time. On older islands, steep valleys funnel runoff toward communities built on coastal plains. On the Big Island, fresh lava terrain can be fractured, uneven, and deceptive, porous in one place, fast shedding in another. The same volcanic processes that created the landscape also engineered its hydrology. In Hawaii, hazard maps are never just about weather or just about geology. They are about gravity moving through a volcanic archipelago. That is what makes the images so unnerving. A tropical state receiving enough rain to collapse structures, lift vehicles, and isolate entire neighborhoods, while elsewhere, an active eruption remains under constant watch. Airports, schools, roads, and hospitals are part of the same equation. They do not care whether the disruption comes from runoff or sulfur dioxide. They only know stress. A road cut by floodwater cannot be used to move supplies. A road threatened by volcanic fallout or reduced visibility becomes another point of friction. A hospital already managing storm injuries does not want a spike in breathing problems from VOG. An emergency manager facing evacuation decisions does not need uncertainty in both the sky and the crater at the same time. The human body experiences these combined threats in a very direct way. Floods are obvious. People can see the water rising against steps, hear the current under bridges, smell the sewage and mud, feel the panic that comes when an escape route disappears. Volcanic gas is different. It arrives as irritation, burning eyes, a throat that tightens, headaches, shortness of breath, a strange metallic taste in the air. For people with asthma, heart conditions, or older lungs, VOG is not a background inconvenience. It is a physiological stressor. The danger is sharper because it can reach far from the eruption itself, and because the storm can move it into places where residents are not expecting volcanic air to be part of a flood emergency. There's also something psychologically disorienting about simultaneous hazards in Hawaii. The islands already live with layered risk: hurricanes, tsunamis, landslides, drought, wildfire, high surf, earthquakes, eruptions. But the public mind still tends to separate them. Fire season over here, storm season over there, eruption risk in this district, flood risk in that valley. Reality is less organized. Once infrastructure is damaged, one hazard weakens the defenses against another. A storm does not have to trigger an eruption to make an eruption more dangerous. An eruption does not have to send lava into a town to make a storm response more difficult. The connection is systemic, not cinematic. And that makes it more serious. History in Hawaii is full of these compounded moments. In 2018, Kilauea's Lower East Rift Zone eruption destroyed more than 700 structures, covered roughly 30 miles of road, displaced more than 2,000 people, and remade the coastline itself. Entire neighborhoods in Puna were erased under lava. At the summit, tens of thousands of earthquakes accompanied repeated collapse events, and Halemaumau deepened dramatically as the volcano reconfigured. That alone would have marked the year. But then Hurricane Lane arrived, soaking parts of the state with extraordinary rainfall. On the island of Hawaii, one location recorded 58 inches of rain from the storm, setting a state tropical cyclone rainfall record. That is not weather brushing past a disaster zone. That is one catastrophe entering the weakened perimeter of another. Even deeper in the historical record is 1868, one of the darkest sequences in Hawaiian geologic history. What began with volcanic unrest escalated into a chain of earthquakes, a major seismic shock, landslides, a deadly mudflow, a tsunami, and then a lava eruption on Mauna Loa's southwest rift zone. In Ka'u, villages were destroyed. People were buried. Coastal settlements were hit by multiple tsunami waves. Lava reached the ocean in hours. The point is not that the present moment is about to repeat 1868 exactly. It almost certainly is not. The point is that Hawaii has a long memory of natural systems refusing to stay in separate compartments. The islands have done this before, stacking hazards, compressing decision time, punishing any illusion that one crisis can be understood alone. What matters now is not simply how much rain has fallen or how high the lava fountains rise. It is whether the larger system is entering a phase of compounding vulnerability. The warning sign is saturation, saturated ground, saturated drainage networks, saturated emergency services, saturated public attention. Once a population has already spent days tracking flood advisories, moving vehicles, watching streams rise, and preparing for another overnight warning, its ability to absorb a second category of risk begins to degrade. People make poorer decisions when every alert sounds urgent. They normalize danger because it is constant. They stay when they should leave because the first evacuation felt temporary. They drive through water because the previous road was fine. Fatigue is one of the least visible disaster accelerants. And Hawaii's physical constraints intensify that fatigue. There are only so many roads, only so many alternate routes around blocked sections of coastline or mountain passes. Communities on narrow coastal shelves and in valley mouths depend on infrastructure that can be cut quickly. On the Big Island, some areas live under long-established lava hazard maps because a single eruption can isolate neighborhoods, even if it does not destroy every home. Flooding works with the same logic. It does not need to destroy an entire district to make daily life untenable. If access roads are gone, if bridges are closed, if power is intermittent, if air quality is poor, then the crisis extends beyond the moment of impact into a slower, more exhausting form of instability. There is another hidden mechanism here, and it is the one most people never see. Time. Floodwater feels immediate. It rises in hours. It kills in minutes. A volcano, especially one erupting inside a contained summit crater, can seem less urgent by comparison. But Kilauea is not dangerous because it is dramatic. It is dangerous because it is persistent. It stays in the regional equation week after week, month after month, changing the atmosphere, changing public behavior, changing official posture, changing what normal even means. An eruption that becomes familiar can be more destabilizing than one spectacular blast, because it trains everyone to live inside a rolling emergency. Then, when a different disaster enters the frame, like statewide flooding, the overlap becomes much harder to manage. And although the lava at Kilauea's summit is currently confined within Oʻahu, the volcano's history offers no comfort in permanence. Kilauea has its own deep magma plumbing system extending many tens of kilometers below the surface. Pressure changes at the summit can matter far from the summit. In 2018, the connection between Kilauea's summit and lower rift activity became brutally obvious when magma drained away, fissures opened in residential areas, and the summit began collapsing in repeated cycles. Modern monitoring is far better now. Scientists can see inflation and deflation, detect earthquakes, map gas emissions, model lava pathways. But better monitoring does not mean control. It means clear warning before a system does what volcanic systems have always done: change. That uncertainty matters because flood emergencies narrow the bandwidth for dealing with change. Imagine a storm-damaged state where airports are strained, roads are blocked, schools are closed, and hospitals are already absorbing the consequences of high water. Then imagine a significant shift in volcanic behavior layered on top of that, an escalation in gas output, stronger fountains, more widespread tephra, or a new phase that demands altered access and new safety zones. Even if none of those happen today, the risk calculation is no longer theoretical. It is logistical. Can authorities communicate fast enough? Can communities move fast enough? Can responders maintain access? A disaster is not only the force that strikes. It is the gap between what strikes and what the system can still handle. The land itself shows the paradox of Hawaii more clearly than any forecast. The islands are beautiful because they are unstable. Their cliffs exist because volcanoes built up mass and the ocean cut into it. Their black sand beaches exist because lava shattered, cooled, and was ground by waves. Their fertile districts exist because ash and weathering fed the soil. Their waterfalls exist because mountains force rain from moving air. The very conditions that make Hawaii visually extraordinary are the same conditions that allow floodwater to accelerate and volcanic hazards to persist. Paradise is not the opposite of danger here. It is often the product of it. This is why the phrase natural disaster can sometimes hide as much as it reveals. There is nothing random about what is happening. Severe rainfall over steep volcanic terrain will always seek the fastest path downslope. Slow-moving low-pressure systems over warm ocean water will always be capable of wringing out immense precipitation. An active summit eruption will always produce gases that depend on atmospheric conditions for where they go next. Add dense development, narrow transportation corridors, aging infrastructure in some districts, and a population spread across islands that cannot simply evacuate inland forever, and the stakes become very concrete. The real story is not that Hawaii is being attacked by freak extremes from nowhere. It is that the islands are revealing, in one concentrated episode, how intimately climate, geology, and human settlement are braided together. There's also a deeper modern question hanging over all of this. Not whether Hawaii has always had volcanoes and storms. It has, but whether the balance between them and human systems is shifting. Warmer air can hold more moisture. Slow-moving rain events can become more punishing when they stall over topography that is already efficient at producing runoff. Communities rebuilt after one disaster may find themselves exposed to another before recovery is complete. The state is still carrying the memory of recent fires, floods, and eruptions. Resilience, as a word, sounds solid. In practice, it can become a thin layer stretched over repeated shock. In moments like this, the language of emergency management becomes brutally practical. Move to higher ground. Avoid flooded roads. Do not enter fast-moving water. Monitor air quality. Follow evacuation instructions. All of it is necessary. None of it fully captures what simultaneous hazards feel like on the ground, because the threat is not just physical, it is spatial and temporal. Which route is still open? Which district is next? Whether the stream will crest before dawn? Whether the wind shift will push VOG into a shelter area? Whether the road to the hospital will hold? Whether the next eruption episode will stay contained? Whether the next storm band is the one that turns inconvenience into catastrophe? And small details become enormous. A culvert clogged with debris. A slope that has already lost its vegetation. A retaining wall undermined by previous weather, a roof catchment system vulnerable to acidic contamination from volcanic haze, a low-lying home built on a floodplain that looked harmless in dry season, a family choosing between leaving early and risking looting or staying late and risking being trapped. This is how disasters are actually experienced, not as abstract maps, but as chains of ordinary decisions compressed under extraordinary conditions. What is especially haunting about Hawaii is how quickly the boundary between spectacle and hazard disappears. Lava fountains draw visitors because they are visually astonishing. Storm surf draws crowds for the same reason. But the camera frame always lies by omission. It does not show the sulfur dioxide concentration just outside the shot. It does not show the slope failure beginning upstream. It does not show the drainage basin filling in the dark. It does not show the emergency crews, who will spend the next 48 hours clearing, rescuing, and triaging long after the images stop trending. Hawaii is one of the most photographed landscapes on Earth. That does not mean it is one of the most understood. The scientific mechanism beneath this moment is almost elegant in its cruelty. Deep below the island, magma rises through its own plumbing system and periodically vents at the summit, releasing heat, gas, and molten rock. Above the island, a slow-moving low-pressure system drags in moisture and destabilizes the atmosphere. Between those two layers sits a mountainous volcanic landscape that amplifies both. It forces air upward into rain. It channels runoff downward into floods. It shapes wind fields that determine where pollution settles. It hosts roads and towns in the pathways carved by all of the above. Nothing here is isolated. The island is a machine built from interacting hazards. And yet, even now, the outcome is not fully written. The floodwaters will recede somewhere first. The volcano may pause again, then reawaken. Another eruption episode may throw lava high into the air, or the summit may briefly quiet while pressure rebuilds below. The storm may move on, or another low may follow before the ground has recovered. Hawaii has seen sequences like this before, when one event weakens the state's ability to meet the next one. The unsettling truth is that the most dangerous phase of a disaster is often not the first impact, but the period when people think the worst is beginning to pass. Because that is when systems fail quietly, insurance gaps become visible, temporary repairs are asked to hold permanent weight. Respiratory stress lingers after the flood headlines fade. Roads reopened in haste carry more traffic than they should. Agencies shift from rescue to cleanup while still watching the weather in the crater. Public attention moves on faster than recovery ever can. And underneath it all, Kilauea remains what it has always been. Not a one-time event, but an active engine in the life of the island. This is the deeper message inside the image of floods and fire striking Hawaii at once. It is not just a rare visual contrast, it is a reminder that the islands exist at the intersection of immense forces that are still in motion. Rain is still being lifted over volcanic ridges. Water is still carving channels through lava-built land. Gas is still rising through rock formed by earlier eruptions. Communities are still living, driving, building, evacuating, and returning inside a landscape that is not finished forming. Hawaii is not a stable paradise temporarily interrupted by disaster. It is a living geologic system that permits beauty and danger at the same time. So, when the flood sirens sound while Kilauea still glows, the real story is not that two disasters happen to share the same horizon. The real story is that Hawaii has entered one of those moments when the architecture of the islands becomes visible, when water, rock, air, and human settlement all expose their dependencies at once. And in that exposure, there is something larger than a headline, larger even than a single emergency. There is the uncomfortable recognition that some places do not break all at once. They strain, they layer risk on risk. They keep functioning until suddenly, one more storm band, one more blocked road, one more shift in the wind, one more pulse beneath the crater, makes the whole system feel thinner than anyone wanted to believe. Tonight, somewhere in Hawaii, floodwater is still moving through darkness. Somewhere else, sulfur drifts above black rock while instruments wait for the next sign of pressure. And the question hanging over the islands is no longer whether nature can do two things at once. It is how much simultaneous instability a place can absorb before the map still looks familiar, but the reality underneath it has already changed.